Hey, AP Calculus students. So I am actually out today. I'm doing this lesson with no students. We'll see how this goes. So I'm going to walk you through the lesson for section 3-4. Today, let's go ahead and start with a warm-up. So take a moment. I want you to freeze the screen. Work on this warm-up for a minute or two with the people in your group. See if you can figure it out. Once you guys have answers for all three parts, unpause the screen. So I'm pausing, just pause for a moment. Okay, so I'm going to assume that you have all completed this problem, and I'm going to walk you through. A theater group is sending out letters to patrons asking for financial support. They have formulated that if X letters are sent, the amount of money donated in thousands of dollars will be f of x equals 1/2 x squared plus 14x plus 90. Note, these are very wealthy patrons. It's going to be a lot of money. So for part A, let's find f of 10. You get f of 10 simply by plugging a 10 into your function. So you get 1/2 of 100, which is 50, plus 140, plus 90. So let's see, 190 plus 90, 280. So that f of 10 is 280. Now let's interpret what that means. So remember, we always start with our input. So 10, x represents the number of letters that are sent. So when 10 letters are sent, all right, the amount of money donated in thousands of dollars, so $280,000 will be donated. That's not bad for sending out 10 letters. I would send 10 letters in a heartbeat to get $280,000. All right, part B, express the rate of change in the money donated with respect to the number of letters sent. That's fancy talk for just saying find f prime of x. So, let's change colors here. Make sure I can see this okay. All right, so for part B, our f prime of x, which is the rate of change of the amount of money donated with respect to the number of letters sent. So f prime of x, well, that would be x plus 14. Because 2 times 1/2 is 1, x plus 14. All right, so for part C, find and interpret f prime of 10. So for part C, so f prime of 10, well, that's just 10 plus 14, or 24. All right, that part's the easy part. Let's interpret. Always start with your input. When 10 letters are sent, input is still x. It hasn't changed, so that 10 still represents the number of letters that were sent. So when 10 letters are sent, the amount of money donated, the money donated, is changing at a rate of, and it would be 24, and then the units for money donated is thousands of dollars, and then the units for x are letters, so $24,000 per letter. So however you want to write that, I'm just going to write $24,000 per letter. If you want to write 24 and then put the units thousands of dollars per letter, that's okay too. This just seems a little bit more intuitive to me to write $24,000 a letter. So what does that really mean? What that really means is if they collected $280,000 for 10 letters, if they send out 11 letters, they should expect to collect $304,000, $24,000 more than when they sent out 10. So roughly something like that. Now, it doesn't work exactly like that, but that's roughly the rate of change. We get this nice positive rate of change of positive $24,000 per letter. Okay, that's the warm-up. Today we're doing section 3-4, which is all about the chain rule. We will be able to, after this lesson, we'll be able to do derivatives of slightly more complicated functions than what we've been doing so far. the chain rule. The chain rule says that chain rule, just so you know, works with composed functions. But when you have one function plugged into another function. So the derivative of f of g of x, not f times, f of g of x, is f prime of g of x times g prime of x. So you do the derivative of the outside function first, then with keeping the inside the same, and then multiply by the derivative of the inside. I will tell you personally, I always call the inside function the guts. So you do the derivative of the outside, the guts stay the same, and then you multiply by the derivative of the guts. Now, Leibniz, you wrote it like this. He said, hey, dy dx is the same as dy du times du dx. U would represent your guts. So you do the derivative of y in terms of the guts, and then the derivative of the guts in terms of x. So you'll see what this means when we do our first example. So in this one, g would be your guts. No problem. Well, I don't want to say no problem. I'm sure there's a problem out there. There's a few where they actually label the functions f and g. But most of the time, it's not in your face that this is chain rule. How do you know when to use chain rule? You use chain rule every single time the guts aren't just the letter x. So if you're differentiating y equals x to the 7th, the guts are just x, and the answer would be 7x to the 6th. But here, when you're differentiating 3x plus 5 to the 7th, the guts are 3x plus 5. That is like your g of x. So it's like the inside function, the stuff that's being plugged into the other function, right? Okay, so how do we do this? If we have to differentiate using chain rule, the method is easier to show with an example than it is to show with a formula. So when you're doing a derivative of a composed function, you do the derivative of the outside part first. So think of it as like, if you don't know what this is, just think of it as something to the 7th. So what would your answer be? It would be 7 times something to the 6th. So whenever you do a derivative with chain rule, just think 7 times something to the 6th. And then, what do you do with the guts? So first, the guts stay the guts. Don't change the guts. You got to keep your guts. But then you multiply on the outside by the derivative of the guts. So the derivative of the guts would be 3. So your answer to this derivative is 21 times 3x plus 5 to the 6th. Now, just so you know, you are actually doing chain rule with every single derivative you take. So for example, if I had y equals just x to the 7th, well, my y prime would be 7 times my guts to the 6th times the derivative of the guts, but the derivative is just 1, which is why when the guts are just an x, we really don't think of it as chain rule because the derivative is just 1, but it's still chain rule. You're multiplying by the derivative of the guts, and the derivative is just 1. All right, you need to apply chain rule every single time the input of your function is not just x. You really apply it all the time, but that's when you need to be on the lookout, is if the stuff you're plugging into your function, if the guts of your function isn't just the letter x, then you always have to multiply your answer by the derivative of the guts. All right, let's see. So let's do this example. Find all values of x at which f prime equals 0 or f prime is undefined if f of x equals x squared plus 1 to the 2/3. Well, the cube root of x squared plus 1 squared. So the first thing that you're going to have to do, of course, is rewrite your function in exponential form. Then you're going to have to find f prime of x. So I want you to pause the video here for a moment, rewrite your function, and then find your f prime. Make sure that you use chain rule. All right, so I'm going to rewrite So this function is the same as x squared minus 1 to the 2/3. So my f prime is equal to 2/3 times something to the negative 1/3. What goes in here? It's always the guts. The guts never, ever, ever, ever change. So keep your guts the same, then you multiply by the derivative of the guts. I'm going to call it d guts. All right, so now if we clean this up a little bit, on top we have a 2 and a 2x, so we get a 4x. On the bottom we have 3 times the cube root of x squared minus 1. We need to find where f prime equals 0 and where f prime is undefined. Learn this, make sure you hear this is important. A derivative is 0 whenever the numerator is 0. Any fraction is 0 when the top is 0. And a fraction is undefined when the bottom is 0. So f prime equals 0 when 4x equals 0, or in other words, at x equals 0. So at x equals 0, our derivative is 0. F prime is undefined when 3 times the cube root of x squared minus 1 equals 0. All right, a little bit of algebra. First thing you do is divide both sides by 3. Okay, cube both sides. You get x squared equals 1. So x is plus or minus 1. So your final answer for all values of x where f prime is 0 or undefined, you have x equals 0 or plus or minus 1. So we're going to learn later on, those are called the critical values. It's where the derivative is 0 or undefined. All right, next example. Find the equation of the line tangent to y at t equals negative 3 if y equals 4 over t plus 2 quantity squared. So take a moment. You know, in order to find the equation of the tangent line, you're going to need a point and you're going to need a slope. To find the slope, you're going to have to find the derivative. So take a moment, pause the video, work this out. See if you can find the derivative and then find your point and your slope and write your equation. All right, so I'm going to rewrite my y as 4 times t plus 2 to the negative second. Now, some people would like to do quotient rule on this. I never do quotient rule when there's a constant in the numerator or the denominator. If there's no variables in the numerator or the denominator, power rule actually is a little bit easier. But if you have variables, both top and bottom, you're going to always want to do quotient rule. So for this, our y prime would be negative 8 times something to the negative third. What's the something? It's the guts. T plus 2 times the derivative of the guts, which in this case is just 1. So our derivative is negative 8 over t plus 2 cubed. All right, we want the equation of the line tangent at t equals 3. So we need a point and we need a slope. So the point would be y evaluated at t equals negative 3, which is 4 times negative 3 plus 2 to the negative second, which equals 4 over negative 1 squared, or 4. So our point is the point negative 3, 4. Our slope would be y prime evaluated at t equals negative 3. That would be negative 8 over negative 3 plus 2 cubed. So that's negative 8 over negative 1 cubed, which is negative 1. So our slope is 8, which means our equation of our tangent line is y minus 4 equals 8 times t plus 3. All right, next problem. All right, having fun with double chain rules. You can have a function inside of a function inside of another function. You could do it like embedded chain rules all day long. It's kind of fun. So let's try this one here. So I'm going to rewrite my y as the cosine of x squared, all raised to the 1/2 power. Remember, when you're doing chain rule, you work outside in, always outside in. So our y prime would be, so we work the outside derivative, which is, think of it as just guts to the 1/2, guts to the 1/2. So 1/2 times guts, never change your guts, to the negative 1/2. Now you have to multiply by the derivative of the guts. So we're going to multiply this by the derivative of cosine of x squared. So you kind of ignore everything that's on the outsides and you're treating it as though you're only looking at cosine of x squared. We know the derivative of cosine is negative sine, so this would be negative sine, guts don't change. So negative sine of x squared. Now the guts that we're plugging into our function is the x squared. If it was just x, then the final derivative would just be 1 and we'd be done. But it's not, it's x squared. So now we get to multiply by the derivative of x squared. The derivative of x squared is 2x. And now we're done. Of course, we got to clean it up. So let's see what's on top. So this 2 and this half can cancel each other out. So what's left on top would be negative x sine x squared, and then on the bottom you would have the square root of cosine x squared. All right, it's time for another new derivative. It's time to learn the derivative of a to the x. You already know the derivative of e to the x. The derivative of a to the x is a to the x ln a. I want to point out that if we were to do the derivative of e to the x as e to the x ln e, well, what is ln e? ln e equals 1. Natural log of e is 1, so the derivative of e to the x is just e to the x. But for this problem, or for this formula, we're doing bases that might be something else like 2 or 5 or other numbers, not just e. All right, let's see if we understand this notation. d2 to the x over dx, so that's the same as d dx of 2 to the x. It's just fancy notation for the derivative of 2 to the x. What's the derivative of 2 to the x? So your a is 2, so you'd have 2 to the x ln 2. And then you just stop. There's nothing else you can do. You can't put those together. There's no simplifying to be had. All right, next one, again, I'm just going to rewrite the notation so you can see what's going on. So d dx of 2 to the 3x squared plus 5x plus 6. Uh-oh, our guts are no longer just an x, which means we have to apply chain rule. So let's do it. So the derivative of 2 to the 3x squared plus 5x plus 6 is 2. Keep the guts the same. Times ln 2. Now we have to multiply by the derivative of the guts, which is 6x plus 5. And this whole big thing, that's the derivative. And there's nothing you can do to simplify it, so please don't try, because it just has to stay like that. So a to the x, in this case, think of it as like not just an x, but a to the guts times ln a, d guts. Oh my goodness, you were wondering when you would have more practice? This is enough practice to keep you busy for an hour. So what I'd like you to do in your groups, you don't have to do all of these, but maybe divvy them up. And so maybe if each of you start on a different letter and then do every 5th problem. So There are 4 people in your group. Divvy up your starting letter between A, B, C, and D. And then if I had letter A, I would go A, and then E, and then I, and then M, and so forth through. So that each person is doing maybe, 6 or 7 problems just to kind of get some review in. So take maybe the next 5 or 10 minutes, and let's see how you do. So work through these problems, and pause it right here so you can have time to work them through, because I'm going to show you the answers in just a moment. One of the things I want to point out is whenever you have a trig function raised to a power, like cosine squared, think of it as cosine x raised to the second power, because this is what tells you you need to do chain rule. So always when you have a trig function raised to a power, put the power on the outside. So for example, like this guy would be the sine of 2x all raised to the 9th. All right, let's see how you did. So take a look at the answers, check your work, talk to your group mates if you didn't get, if you missed any, see if you can figure out what happened. And here ended the lesson. So what I want you to do now, once you've finished all of your practice, is go online and start working through your homework. Feel free to talk to each other while you're doing your homework, as long as you stay focused and you're getting your work done. Have a great day.